Welcome back. In this session, we'll talk about theory and frameworks of integrating technology into education, particularly in the way it's discussed in the first chapter of Howland and Jonasson. So the sort of strongest theory in the text, and probably as you think about technology for decades, is Dave Jonasson's idea of the characteristics of meaningful learning. And just things like there's a strong active component. Kids have to construct knowledge. There's a collaborative, cooperative a part of constructing knowledge. It has to be authentic, meaning it needs to be relevant. And intentional, there needs to be a purpose for it. This is the most abstract of our models, but it's probably the most worthwhile for you to understand deeply. Now, the models don't have to be complex. The important thing is that the theories and frameworks can make sense to you. So one of your goals for this week and for our course is to make these theoretical frameworks yours. So here's a very simplified approach to meaningful, engaged learning. So learning by doing, well, that's the act of learning. Real-world connections, that's authentic. And this describes a slightly different arrangement: student voice and choice, the role of students, higher order thinking, but it doesn't have to be as abstract. One of the elements we'll touch on throughout the text and throughout the course are the different levels of learning. And there are two hierarchies of learning that are popular. The one that's most popular in higher ed is Bloom's taxonomy of learning. And the idea there is that there are different kinds of thinking, different kinds of learning. And something like remembering somebody's name is kind of easy. That's a low level of learning. Whereas creating or designing a new experiment is something that would be a much more complex task to learn. So there's increasing difficulty. The top levels, the creating, evaluating, and analyzing, are often referred to as higher order learning or higher level thinking, something like that. The idea being that remembering, understanding, applying would be lower levels. Webb's depth of knowledge is the same idea, but this is what's used more in schools because it's simpler. And why make it simple? So the depth of knowledge idea, instead of 6 categories, has 4. The two lower levels are recall, meaning just remembering something, and skills and concepts. Can you do something, and can you kind of explain it? But people like the way that the higher levels are described. So level 3, strategic thinking, like if you can develop a plan, you're thinking at a much higher level. And if you can conduct an investigation, collect data, and analyze the results, then you're working at a much, much higher level. So you'll encounter Webb's depth of knowledge framework at the teacher level more than the higher ed level. Now, both of these seem simple when you see the individual diagram, but the way they're implemented adds complexity. So for example, level 1, recall, this is a diagram to help you realize, oh, if you're just repeating or recalling or reciting or naming something, that's pretty easy. That's level 1. A little bit harder is if you're graphing something, changing its format, or classifying, figuring out cause and effect, estimating, comparing. Level 3, the strategic thinking, is where you're doing something else. You're adding more of your own thought to it. You're revising, critiquing, constructing, comparing. And then level 4 is the creative part. We are creating, designing, critiquing, proving something. So as you see diagrams like this, don't let the complexity and detail overwhelm you. It's actually pretty simple if you look at it in that way. Now, just as there are academic standards for English and math, there are also academic standards for technology, and the best known are the ISTE standards. That's the International Society for Technology in Education. And they have standards for students, faculty, administrators, and coaches. And just to see how they chunk it up, notice the importance that they put in creativity and innovation. So students should learn to use technology to create and innovate, and communicate and collaborate, to do research and find information, critically think. They should know enough to be good digital citizens, and they need to know how to operate different kinds of technology. So you'll see the ISTE standards, sometimes called the NET standards, National Educational Technology Standards, NETs. So how do teachers learn to do this in class, to actually take technology and implement it into their lessons? Well, they do it in stages, and Puentedura's SAMR model is kind of the simplest model of how teachers evolve in their sophistication in using technology. So teachers start with the S. Substitution. They substitute new technology for existing ways. A word processor is used instead of a typewriter. It does the same thing. There's no functional difference, but they've integrated the word processor at a low level. Then the augmentation level is when they say, hey, there's a spell checker in here, so I don't want to see any spelling errors, and you can cut and paste so you can move things around for simple revisions. Won't you like that? So that's doing something that a typewriter couldn't do. So these are the enhancement levels. They're low levels of integration. They don't change the way kids learn. We want to focus on the transformation levels, the modification and redefinition. So in modifying, hey, with this word processor, I want you to do 3 drafts, but you don't have to rewrite the whole thing. You can revise using this new tool, and the end product will be much better. It changes the way you think about writing. And in redefinition, and we're going to have peer review and peer editing, something that we couldn't do with the typewriter and paper. So the SAMR model is one way of expressing how teachers grow in their understanding and skill in integrating technology to make learning more meaningful or more transformative. So where does technology fit in the larger education scheme of things? Mishra and Kohler came up with a model they call the TPAC model. It used to be that a teacher needed to know content. Hey, you're pretty good at math, you could be a math teacher. But that wasn't good enough because kids weren't learning. Because the teacher needs to know how do kids learn best. So they need that pedagogical knowledge. So now, teachers need both the content knowledge and the knowledge of how kids learn, pedagogy. In today's schools with technology and online learning, teachers also need technological knowledge. So the TPAC stands for technology, pedagogy, content. And this little area in here where the Venn diagram intersects is what a modern teacher needs to know. They need to have technological, pedagogical, content knowledge. Now, the TPCK is unpronounceable. So they bought a vowel, they added a letter A. Just to make it pronounceable, the A doesn't mean anything. TPAC, where it fits. Well, these theories and frameworks are kind of easy to kind of show as a diagram, but they're tough to implement. So don't be surprised if they all seem to be a muddle, a tangle in your head. That's normal. So let's review what we covered. We shared some models of hierarchies of learning, and we talked about where does technology fit in the overall scheme of education. How can you organize the ideas of meaningful learning? How does teaching evolve? And what are some technology standards? So in a moment, I'd like you to pause this video and see if you can connect each of these ideas, each of these frameworks to their ideas. Pause it now, please. Okay, let's see how you did. So for hierarchy of learning, there are two of them. That would be Webb and Bloom. Where does technology fit? That's TPAC. Meaningful learning is Jonathan. The stages would be the SAMR model, and the technology would be the ISTE standards. So, I hope you got a good introduction. It's no more than an introduction, and see you next time.